Hello. In this video, we're going to be taking a look at the third topic from Thursday's quarterly exam on transformations and specifically relating them to special functions. So in this case, we're told the parent function, or there's a reference made to the parent function for the absolute value of x. And we're told to graph g of x given some rule. It says given that f of x minus 2, close parentheses, and then plus 4 outside of the parentheses. So the tricky part here, we don't have an explicit equation for g of x. We don't have anything that we can physically type in right now into our graphing calculator, which obviously makes things a little bit more difficult. But if you start by thinking or breaking this up into what you know about transformations, take a look at the minus 2 in the parentheses here. It doesn't matter that it's written in this function notation format, the same rules apply. The minus 2 is in the parentheses, indicating our IHOP rule of kind of the opposite of what it's saying, of 2 units to the right instead of the left here. Remember, anything inside is a horizontal movement, and it's the opposite of what it's referring to. Minus 2, you usually would think like 2 to the left, but it's the opposite, 2 units to the right. And the plus 4 is going to be 4 units up. That's a vertical translation. No tricks with the up or down movements. It's just kind of straight up, no pun intended. If it says plus 4, it's 4 units up. No tricks. So there's one of two ways we could graph it. You wouldn't actually graph this because I'm going to move it in a second, which obviously you guys don't have the capabilities of. You can think of the parent function, the absolute value of x, and think about applying this rule we just discussed. So in other words, if I slide this 2 units to the right, 1, 2, and 4 units up, 1, 2, 3, 4, that would be g of x. It's as simple as that. Now obviously we don't have these, or you wouldn't have these if you're doing these on paper, this ability to kind of like copy something or grab something and slide it. But we can think of it in terms of thinking where the vertex is. So we know the vertex for the parent function is at 0, 0. So hey, if I'm moving 2 units right and 4 units up, this is my new vertex at 2, 4. And then we plot our kind of symmetric values around that. So that's one way of doing it. The other way I would recommend would be if you'd like to write an explicit rule for g of x, knowing kind of what we discussed when we first dove into this. Hey, 2 units right. It would be the absolute value of x minus 2 in the brackets, in the absolute value bars, and then a plus 4 outside. What's the advantage to this technique? With this, we could actually get into some of the regular graphing algorithm that we're used to. Hey, make a table of values, enter it in the calculator, symmetry, all that fun stuff. And we're obviously going to get the same graph that we started with up there, 2, 4, 1, 5, and 0, 6, 4, 6. This is the same picture I had earlier. So either by making an equation and making a table of values based on the transformation, or just simply thinking, hey, the parent function looks like this. If I slide every single point, 2 units right, 4 units up, what is it going to look like now? Either of these techniques will help you answer this question and graph the transformation rule. Okay, so some follow-up questions with this, and this is what you'll see on the quarterly as well. First, identifying the transformation. So we had a horizontal translation. That's just a fancy word for saying slide. I'm just going to abbreviate it. 2 units right. And then we had a vertical translation. That means up or down. I'm just going to write a VT. 4 units up. 4 units up. Okay. That was the very first thing we did, kind of what helped us graph it, no matter which method we used. 2 units to the right, 4 units up. Okay, the domain and range. This gets a little tricky for some people. First, just knowing that domain refers to your x values and range refers to your y values. With the domain, what x values are included in this graph or are permissible, are allowed in this graph? Everything. There's no restriction on what you can plug in for x. I could technically take the absolute value of negative 5 billion, and by the same logic, I could take the absolute value of positive 5 billion. There's no restrictions on what I plug in here. It's not like it's not allowed or my calculator would give me some type of error message. So for my domain, I can write that in one of two ways. You can say all real numbers, like in other words, everything works. Or, you don't have to write both of these, so I want to stress that's or here. The other way of writing this is with your infinity symbols, from negative infinity to positive infinity. In other words, everything works. With infinity, we don't want to use the little equal to. You can't equal infinity, so notice each symbol is just plain. It doesn't have the little line underneath. Now for range, we're a little different. Just by looking at the graph, obviously vertically, up and down, this graph doesn't continue on forever in both directions. Going up, it does. Okay, we're going to reach, in terms of y, positive infinity. This graph's going to keep going larger and larger, but it's kind of like a cap here. In other words, it doesn't go below this line. And that value is 4. We're talking in terms of y. So 4 is kind of our key number. It's where y begins, and y can equal 4, right? It's that physical point at 2, 4. And then it could be anything kind of greater than that. Goes on for infinity, vertically. You can write that like that, or with that kind of compound notation, or you could just simply say, hey, y has to be greater than 4, or equal to 4. Both of those do suffice. Okay, that's domain and range. So just a quick reminder, domain referring to your x values, range referring to your y values. Range values can be a little tricky with these. So think vertically, up and down. Where am I starting? And is there a cap at some point? So in this case, we started at 4, goes on forever, vertically to positive infinity. So from 4, including it, it's a little equal to sign, to infinity. Okay, so as a new graph, h of x is defined by this rule. So whatever we just had for g, you multiply it by negative 3. There's no graph here, so just kind of a quick follow-up. Describe in words what happens to the graph of g of x to produce h of x. So what would happen in words? So again, another transformation question here. Two things would actually happen. The first has to do with that negative sign. Okay, that negative sign is going to reflect it. You want to be careful here. Some of you guys have lost points in the past with this. You want to be specific. Some of you guys just write the word flip. You reflect it over the x-axis. Okay, in other words, instead of a normal looking v, it's going to be an upside down looking v, almost like a little caret that we use for exponents on your calculator. So it's going to go from looking like this to now roughly, very roughly, looking like this. Reflects it upside down. It's downward now instead of upward. And the second transformation is the 3. Multiplying the equation by 3, think about that. Every single y value is going to be multiplied by 3. So you can imagine this is going to be quite large here, or the value is going to get quite large pretty soon. So this is going to be a vertical stretch. The rule with this has to do with the relationship to 1. Obviously, multiplying something by 1 wouldn't change anything. But if you're between 0 and 1, the graph is going to get wider. The values are going to get smaller, more spread out. If you multiply by anything larger than 1, the values kind of shoot up a little bit more rapidly. And instead of, we could use the word narrow here, vertical stretch and more narrow. And just a quick comparison, if that's the parent function, the vertical stretch refers to the fact that it now looks like this. Okay, it's like almost like kind of pushing in the sides or vertically kind of peeling the top and the bottom, pulling it almost like silly putty. It's getting skinnier or more narrow. Okay, so those are the two transformations for h of x. And you can write those obviously however you want, but those would be the two movements. So just to recap, this question had a few parts, but none of them were really that confusing. Just basically applying your transformation rules of knowing what a horizontal transformation is, a vertical transformation, and don't forget with the horizontal we have IHOP rules to consider. Domain and range we've seen applied in multiple areas. Domain your x values, range your y values. So just always look at the graph. Luckily we had to go through the effort of graphing here, so we would just look at our picture and kind of say to yourself, hey, what works for x, if not anything, and what works for y? Is there a limit? Is there some point where it starts or stops, or is it everything? And that's it. So thank you guys for watching. If you have any questions, be sure to let me know.